as we continue to look at graphing and see what information calculus can give us about the graphs that we did in college algebra, we're going to start off this lesson with what's called Rolle's theorem. Rolle's theorem then becomes the basis for the mean value theorem. And once you get the mean value theorem, you can kind of think of Rolle's theorem as a specific subset of the mean value theorem, which almost makes you feel like you've got the chicken and egg thing going on there. So it'll make more sense after the next video. So in this video, we're going to do Rolle's theorem. And in the next video, we're going to do the mean value theorem. And I'll try to tie it back together at the end of that video. Don't forget there's some practice problems in the description below. And the link to the next video will be there too. All right, so we are going to start off with the definition of what Rolle's theorem is trying to get across to us. And Rolle's theorem says, if you have some function and it satisfies the following hypothesis: 1, f is continuous in some closed interval. 2, f is differentiable on this open interval, not counting the end pieces, all right? And if the functional value evaluated at A is equal to the functional value evaluated at X is B, right? Then there is at least one number, and that should be just a C, in AB such that f prime of C is equal to 0. Okay? So what that means is you have some function, all right? And it's just doing its thing. And if you could find two places where the y value is equal. So here's two y values that are equal, right? This would be where x is a, and this is where x is b. If the two y values are equal, then somewhere in between here, right, the derivative has to be equal to 0. And remember, the derivative says that's talking about the slope, right? So it's saying somewhere in between there, the slope is 0. And I think it makes more sense if you actually think about, we have some point in the middle of space. And let's say this is when x is a and this is when x is b. There's only a few ways to get from a to b. I mean, there's like thousands and millions of paths, but there's like maybe just 3 ways you can get there. In effect, is you could go straight over. That's one way. Now, if you go straight over, the slope through the whole thing is 0, right? Because it's a flat line. It's a horizontal line. So you could go straight over. That's one possibility. You could arch up and go over from A to B. So in order to get back to the same height, right, if you start at a certain height here and you're traveling over, in order to get back to the same height, if you went up, you have to go down, okay? Or you could have started at some height A, gone over to B, and maybe you dipped it down. But then you had to reverse directions to get back to the same height. Or you could do any combination of these things and have A and B and just squiggle around, okay, until you get there. And that would give you a number of different places where you have turned. You may have remembered these from college algebra's turning points, where it talked about the maximum number of turning points, which was 1 less than the degree of the polynomial. That's what you dealt with in college algebra, was polynomials pretty much. All right, so the concept is if you start off at a height and you end up at a height, you had to have reverse. If you've changed directions, like you're going up, if you're increasing, you had to come back decreasing. So right here where you change directions, the slope is 0. Or you could have decreased, increased, and the slope is still 0 somewhere in between. All right. Now, so let's do a problem, and let's consider f of x is equal to the square root of x minus 1/4 x. And we're going to consider just this interval. And this would be a, and this would be our value for b. So those are x values for a and b. Now, in order to to justify using Rolle's theorem to find any place in that interval where you would have what's a critical number, right? And they're going to call it C for where the slope might be 0. You have to see if the height when you use x is 0 and x is 16 are the same, right? But you have to verify that this thing is differentiable and continuous. So the first question was, is it continuous? Okay, well, 1/4 x is a polynomial. It's definitely continuous throughout, right? From negative infinity to infinity. The square root of x is not continuous from negative infinity to infinity. It's actually continuous from 0 to infinity. But since we're looking at 0 through 16, and when you add something that has value from 0 to 16 to something that has its own value from 0 on, it is continuous. There's no breaks in this area right here. All right. Now, also since it's a combination of a square root and a polynomial, we should be able to take the derivative of any point at any point between 0 and 16. So it is differentiable. So it's continuous from 0 to 16, and it's differentiable within that interval. You know that sometimes my writing just sort of leaves me cold. And every time I do one of these videos, about a minute or so in, 5 minutes in, after I start writing, it freezes up and won't let me erase. So we're just going to talk about this for just a second. So remember, you have to say if these two things are not true in this interval, you don't know for sure that it's going to have a point where the slope is 0. It may have a critical number, but it's not necessarily going to be the slope is 0. So let's get started on part 3, where we're trying to see if the two heights are the same. So we would say, what is f of 0? So f of 0 is the square root of 0 minus 1/4 times 0. So this is 0. F of 16 is the square root of 16 minus 1/4 of 16. So this is 4 minus 4. So f of 16 is equal to 0. Now they don't have to be equal to 0. What they have to be is equal to each other. And so this is true. So we can say that somewhere, so those are my 3 cases that I have to verify, right? So then I can get busy and say there must be some place when I take the derivative of the original function. So we're taking the derivative of the square root of x minus 1/4 x. It's 1/2 x to the minus 1/2 minus 1/4. So this is supposed to be equal to 0. According to Rolle's theorem, I should be able to find a place where the slope is 0. So 1/2 x, let's do it this way. 1/2 square root of x is equal to 1/4. And if the numerators are equal, then the denominators have to be equal, or you could cross multiply. So the square root of x is equal to 2. So when you square both sides, you get x is equal to 4. But it didn't ask you what x was, it asked you what c was. So depending on your teacher, so much of this is depending on what they want, is they might be satisfied with x is 4. And if the question had said find the value of c, then we would need to do it this way. All right. Now, just so that you can see what this looks like, what you just found. Here in the red is this square root of x minus 0.2514 x. And then the blue is the tangent line that shows you that it's a horizontal line. So right at this point right here, the slope is 0. Okay? And that's using decimals, which they're really kind to let me use. I always try to give them credit. All right. Now let's look at this. This is the famous absolute value function where you would have, this is f of x is equal to the absolute value of x. And if we wanted to talk about the interval from -2 to 2, we could go through here and show that f of -2 is equal to 2 and f of 2 is equal to 2. So f of -2 is equal to f of 2. But if you didn't consider the part about steps 1 and 2 where is it continuous? Yes, it is. It is continuous between -2 and 2. Is it differentiable? No, because the slope here on this side is a -1, which is the derivative value throughout. Okay, the slope on this side is a +1, but right at this point with this sharp change right here, it is not differentiable. So there is not a slope of 0 right there. Okay, you could draw a flat line there, but it is not differentiable right here at this point because of the sudden change from -1 to 1. For something to be differentiable there, because remember you're doing these limits, right? It's limits coming in from the left and from the right. But in order to be differentiable there, it actually has to kind of fade in, right? Where, you know, here's your slope here and your slope here and your slope there and your slope there. But on this side, see how they're starting to kind of level out and then they meet right here. So they have to come in like this and meet and sort of fade into each other in order to be differentiable. So this one would not, so it would fail. So even though it's continuous, and this is true, okay, the fact that it's not differentiable, you would get a C value, right? C is 0, but it is not where the slope is 0. So be careful what you're saying, okay? So let's do another one. Excuse me. So let's use Rolle's theorem to find where the slope is 0. Or see if there is a place, right, where it's 0 between -2 and 2. So 1, we would have to, and 2, we have to decide if it's differentiable and continuous, right? And since it's a polynomial, it is continuous. And since it's a polynomial, there's no reason it's not differentiable in that area. So we would have to prove that. And then we're going to start doing our is it at the same height concept. So f of -2 is -2 cubed minus 4 times -2. So this turns out to be 0. F of 2, excuse me, is 2 cubed minus 4 times 2. So this is 0. They don't always turn out to be 0. There'll be one here in a minute that doesn't, but it just sort of makes the math easier here. So I know it's differentiable. I know it's continuous. I know that the heights are the same. So there must be some x values between -2 and 2 for this curve where the slope would be 0, where it would have a horizontal tangent. And these are critical points. So what we do is we take the derivative, which is 3x squared minus 4, and we say, where would that be equal to 0? So 3x squared is equal to 4. X squared is equal to 4/3. Square root both sides, x is plus or minus 2 over the square root of 3, right? And depending on your teacher, okay, some of them are going to want you to rationalize that. I do not. In my experience, as limited as it is, I've worked with scores of teachers. Most of them do not make you rationalize the denominator in calculus, but it sort of depends. Okay, So I think that there's possibly a location where x is the positive 2 over the square root of 3 and minus 2 over the square root of 3, where it changes from increasing to decreasing or decreasing to increasing, and the slope would be 0. But I'm not real sure exactly what this value is, so I ran it on my calculator because I don't frankly have memorized what 2 over the square root of 3 is. So it's plus or minus 1.1547. And since we were interested in between minus 2 and 2, yes, that is. So that, yes, my values are in that interval. You know, sometimes you get answers for where something's equal to 0 that are not within the interval that you want, and you would discard those because that question said, I'm only interested in these numbers in the interval. So if it's outside the interval, you just discard it. And to show you what this looks like, okay, this is the y is equal to x cubed minus 4x. And here's this is actually 2 over the square root of 3. And this is minus 2 over the square root of 3 for x. Okay? All right. Now, it says suppose you have a function f of x is equal to 1 minus x to the 2/3. And I'm curious about the interval from minus 1 to 1. All right? And let's say your teacher says, show there is no value for c in minus 1 to 1 where f prime of c is equal to 0. Okay? And why does this not contradict Rolle's theorem? Okay? So let's just for grins, okay, say, okay, what is f of minus 1? It's 1 minus 1, excuse me, 2 over 3. So that's the cubed root of negative 1, which is negative 1 squared is 1. So 1 minus 1 is 0. It's definitely stuck on here for today. And f of 1 is 1 minus 1 to the 2/3. So this turns out to be 1 minus 1, which is 0. So yes, that part of it does meet Rolle's theorem. But remember, Rolle's theorem says it has to be continuous and it has to be differentiable, right? So if you look at taking the derivative, you get minus 2/3 x to the minus 1/3. So this would be minus 2 over 3 cubed root of x. And there is no way to get 0 when the numerator is negative 2. You could get 0 for x, but that just makes it undefined, right? But to get equal to 0, the numerator has to equal to 0. So this is not going to be equal to 0. Now, why doesn't that contradict Rolle's theorem? Because Rolle's theorem says it has to be differentiable to start. So you can do this math all day long, but you can't get past is it continuous? Yes. Is it differentiable? No. Okay, so if it fails the differentiable, then you can't say that there's some sort of location where the slope is 0. So this is what this graph looks like. And it's not the absolute value one, but you see how the slope increases and then sharply turns and decreases? So it is not differentiable right there. And we saw right here that when x is equal to 0, that's a problem, right? So here's x is equal to 0. And now you see why it's a problem. All right. Now, let's do this problem. All right. And it says the height of a ball thrown upward with an initial velocity of 48 feet per second from a height of 32 feet above the ground can be described by f of x equals, and this is a very pale negative sign, 16t squared plus 48t plus 32. And it's not a coincidence that this 32 is the height above ground and this is the initial velocity. If you had physics yet, then you've seen this formula. And it says, what is the height of the ball at t is equal to 1 and t is equal to 2 seconds, and explain what you get. All right? So this should be a t. I typed that up and didn't even notice that the variables didn't match. All right, so f of 1 is minus 16 times 1 squared plus 48 times 1 plus 32. So you would have, after you clean this up, 64 feet. F of 2 is minus 16 times 2 squared plus 48 times 2 plus 32. And surprisingly, this turns out to be 64 feet. So see how f of 1 is equal to f of 2, which, thank goodness, it's not 0 again, because it doesn't have to be both zeros. All right. They could both be 2/3. They could both be the square root of 4, whatever. All right. So the heights are the same. Now, why are they the same at 1 second and 2 seconds? And what it is, you had a ball. You threw it up, right? Here's ground level. So this is 32 feet from here to here. Okay. Threw it up, and it came back down. At some point, it would hit the ground, unless you caught it. Okay. So, and at some point up here, a second after you threw it, it's up here to 64 feet. And then it comes up at some height, and then it comes down past 64 feet on the way by. So what does this mean? Why the height is 64 feet at 1 and 2 seconds? Explain the result. The explanation is it passed 64 feet on the way up, and it passed 64 feet on the way back down. All right. So what does Rolle's theorem help us to understand about what happened between 1 and 2 seconds? And Rolle's theorem says, and get back up here, this is continuous, it's a polynomial, and it's differentiable. And Rolle's theorem says that at some point, if you have the same height and the same height at some other x value in between, if it's differentiable and continuous, the slope must be 0. Right? Okay. Now, let's talk about this in a realistic sense. Okay, if right here the slope is 0, then what has happened is, remember this, the slope is the derivative, right? And the derivative of a position function is a velocity function. The derivative of a velocity is acceleration, and what you don't hear very much, but to talk about in engineering, is the derivative of acceleration is what's called jerk. Okay, so anyway, but since this is a position function, when I take the derivative of it, all right, I get a velocity function. So if I take the derivative, I get minus 32t plus 48, and I can see where that's equal to 0. And this happens at 3.5 seconds. Okay, so at 1.5 seconds, the functional value of the slope is 0. So what this is saying is the velocity is 0, in case you want to kind of talk about it a minute. And that makes sense, doesn't it? Because if you've thrown a ball up, you can watch it. It's actually easier if you watch somebody else throw it up. You can see it, and you launch it at some certain speed. And as it goes up, it starts slowing down until right up here it stops for just a teensy fraction of a second, and then starts to fall back down. Okay, so at the top, as it changes directions, the slope is 0, the velocity is 0, and that's one of those things that we often get into trying to find out in some sort of real world application, where we're trying to see when the velocity is equal to 0, because potentially we could be changing directions at that time too. So this is the end of the Rolle's theorem discussion. The mean value theorem is going to be the very next video, I'll refer back to Rawls, and then we'll kind of try to tie the two pieces together. But I hope this helped a little bit about what Rawls' theorem means and what you can use it to find, and to be very, very careful that it has to be differentiable as well as continuous. And so just finding where the two heights are the same is not going to be enough, especially if your teacher's trying to kind of make you think critically and they throw in one of those questions where you're not supposed to be working it because it's not meeting the conditions. So be careful. All right, now see you at the next video.